Hey everybody, welcome back. It's 2023 and it's Advent of Code time. If you haven't seen the 2021 playlist or the 2022 playlist, hi, my name is Ryan. I do this every year. I try it for like a week and then I fail. What's Advent of Code, you might ask? That's a very good question, actually. Let's switch on over to an empty Google Chrome tab. This is Advent of Code. um, Advent of Code is a thing that happens every December. There are, what, 31 days in December or something, and 30 questions. I don't know how many. I never finish it. The point is, there are programming challenges, and you can use any language you like to solve them. And so every year I like to do it in Elm, which is my favorite programming language ever. So I wanted to get started. This is the first video, so I wanted to dive right in. Basically, how the video is going to go is I'm going to read the problem. We're going to see it for the first time together, and then I'm going to walk you through how I solve it. And then on the right side here, you'll see the answer, and we'll plug it in and see if we're right. So code on the left, stuff on the right, and then you can try it yourself. If you want to pause the video here and try this on your own, you can go to what is it, adventofcode.com/2023, and all I did was I signed in. It knows my name because I signed in with GitHub. And that's pretty much it. So that's the whole spiel. Let's dive right in. I'm going to make this full screen again, and we're going to click on day number 1. Oh, all right, day 1, Trebuchet. Something is wrong with global snow production, and you've been selected to take a look. The elves have even given you a map. On it, they've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore snow operations, you need to check all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day of the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You try to ask why they can't just use a weather machine. Not powerful enough, and where they're even sending you, the sky, and why your map mostly looks blank. Looks mostly blank. You sure ask a lot of questions. And hang on, did you just say there's a lot of text here? There'll be a problem here somewhere. All right, and hang on, did you just say the sky when you realize that the elves are already loading you into a trebuchet? I think that's how you pronounce it. As they're making the final adjustments, they discover that their calibration document, your puzzle input, has been amended by a very young elf who is apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values of the document. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single two-digit number. For example, 1, ABC2, P, blah, 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 all this stuff, A, blah, 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 all the way to F, and then trebuchet, the 7. So in this example, the calibration values for those 4 lines are 12, because we found a 1 and a 2 on line 1, 38, because we found a 3 and an 8 on line, and then we found 1 and 5 here. So that's 15, and then 77. So it looks like if there's only 1 digit, so if 7 is the first and the last digit, so that's what we combine together for 77. So consider your entire calibration document. What is the sum of all the values? So they add all these numbers together, and that's how they get 142. So how this works is I'm going to get a unique puzzle input, but before I click on my puzzle input, let's start with the sample input and see if we can get 142. So I'm going to copy this over. I'm going to do a control tab over here, and this is our code editor setup. So if you haven't followed along before in previous years, all we're doing is we are opening a new tab and going to ele-app.com. There's going to be a link in the description, but it's basically CodePen for Elm. And what it allows me to do is it allows me to just paste in puzzle input. Let me make this a multi-line string. And then when I hit compile, you'll see that that text and all the new lines and stuff is going to be available here. So I like to make my puzzle input go on its own lines. And then what we're going to be doing is we're going to be using Elm's pipeline operator to transform this input one step at a time to the answer that we're looking for. So an example of that is if we start here, one thing I might want to do is I might want to trim off the strings here. So I'm going to use Elm's string.trim function. And when I hit compile, you're going to see that that trims the strings off the front. And then maybe next what I want to do is I want to break this big block of text into multiple lines using Elm's string.lines function. So now I've got a list with each individual line in its own place. And then what we're going to do is we're going to loop through that list. Hopefully we're going to be able to get turn this string into 12, turn this big crazy string into 38. Yeah, let's just dive right in and try it out. So when I'm working with a list in Elm and I want to transform each individual value, I use list.map. And how list.map works is you give it a function that just runs on one item in the list, and it's going to run it for every single item. So what we want is we want something that takes one ABC2 and returns 12, which is a number. So we can say to number. Let's see what they called it in the puzzle. They called it calibration value. So I'm going to use that terminology because that is what the puzzle says. So to calibration value is a function that we haven't made yet. So it's going to take in a string and it's going to return a number. As I'm starting to build up like the answer here, what I like to do is I like to leave off these optional type annotations. So by using 2 dashes, I'm just commenting out this line and I'm saying, okay, let's just take in the input and just return it as is. So if I run this code, it shouldn't give us any different output. It should still be the same thing. I took in my initial input, which is just each line one at a time. Let's call this line to make it a little bit easier to understand what's coming in and what's getting spit out. And what you can do here is for each individual value, maybe you want to run some code on that. So if I wanted to get the length of each of these, I would just take the line and I'd keep using this pipeline operator to say take that line and pass it into the string.length function. So here you'll see that not just the first element in the list, but every single element in our list, we got the length of it. So it said this is 5, this is 11, this is 11, this is 10. Unfortunately, string.length is not what we're going to be using to solve this puzzle because what we need to do is we're going to need to filter out values that aren't numbers. So we're not going to be able to use that code. But what we can do is we can use list.filter. Well, first let's make a list of characters. So I think this works. Cool. So here I have a string.toList. I'm going to do a word wrap thing here. Let me just hop into this HTML and see if I remember how to do that. White space pre-wrap. Great. Okay. I'm a lucky guy because sorry, I'm trying to make this not be brushed up against the thing. This is just a little bit of CSS that I'm using here to make it so that we can see all the text. And I'm going to add a little bit of line height here so that the lines have some spacing. This is an Elm. This is just CSS. We're going to add some more. Boop. All right. Last time, I promise. Okay, so we can hide this here. And at the end of this, I'm going to have, I'm going to take this, I'm going to click save, and I'm going to share the link to my solution in the description. So if you get stuck or you want to see how it works, maybe if you're following along, your solution doesn't quite match up, you can just steal my code and see how it works and tweak it and have some fun. Okay, cool. So what I did with string.toList is I took a string and the string.toList function, if we want to take a look at how it works, this is the official Elm docs. Sorry, I have this full screen, but all I did was I clicked here in this doc thing, and that took me to this these docs. So what I was trying to do here with the toList function is I was trying to convert that list or that string into a list of characters. And so now we're going to have a list of characters, and we're going to be able to decide, hey, for each one of these characters, is this a number or not? I think there's actually a helper for this called string.filter. Let me check to see if that's true. I don't need to like scroll through all these. What I can do is I can just search for filter, and sure enough, there is a string.filter. So maybe toList wasn't necessary. Let's just use filter directly and try to use a function to determine if each individual character is a Boolean, and we can get back that string back at the end. So let's take a look at that. So instead of doing this, we're going to say filter. And what I want to do is I want to say string.filter char is digit. I think that's a built-in function. Perfect. Okay, so Elm also comes with this char module. So if we go to the top, I think one of my favorite things about Elm is the core library. It just has a lot of really helpful functions. So char is uppercase, which will return true for capital letters, is lowercase for lowercase letters, alpha, alpha num, and then there's one called isDigit, which is perfect for this puzzle because we don't care about all the noise. All we care about is the numbers. And so what we can do is we can just take the first and the last digit, and then that'll be our final value. So the next step is we're going to try to get rid of the 2, 3, 4, and when we get 7, we're going to try to take the 7 and take the 7 from the end. So the way I'm going to do this is I'm going to use a let expression. So I'm going to say numbers, just the digits actually is what I'll call this. And all that work we did, we're just going to put that in a local variable called just the digits. And that's going to be a string value. And then what we can do is we can say, let's just take the first character on the left, just the digits. So hopefully this will return 1, 3, 1, and 7. 1, 3, 1, and 7. That's perfect. And then what we can do is we can concatenate these strings. String.concat, is that a thing? We can do, well, a little bit easier is we can do, I think string.append is what I'm looking for. I don't have to remember it. I can just Google it. Or Google it. I can just look it up in the docs here. So string concat. So I want to use this function, which takes a list of strings and returns a string. So concat's the one I'm looking for. So if we give it 3 strings, it'll slap them all together. So what I'm going to do is use string.concat. And then I'll take the leftmost digit. And I'll use string.write to take the rightmost digit. And then I have 12, 38, 15, and 77. And if we look at the puzzle, those are the numbers that we're hoping to find. 12, 38, 15, and 77. And so the next thing we need to do is we need to add them together, and that gives us the answer we're looking for. So if I tried to add these things together, I would get, you can't add together like words in Elm. So what I have to do next is I have to take this string, and then I have to, I'm going to try to turn them into integers if I can. So what you'll notice is it worked, but we've got all these weird just values here. So if we take a look at how string to int works, Elm doesn't crash. So the way it handles giving invalid input, like if we gave it banana and asked it to turn that into a number, the way Elm handles that is it gives us a nothing value instead of just always giving us a number and then crashing sometimes. So it's up to us to get rid of any elements that basically are invalid. So the way we can do that is we can use filter map instead of map. And what filter map does is list that filter map as a special list function that takes a function, it runs it on all the values, and if that function returns a maybe, it's only going to keep the values, only going to keep the numbers that are actually valid. So if I hit compile, what that's going to do is that's going to strip all the just prefixes from here. So by doing that, I'm going to have 12, 38, 15, 77, and this is my favorite part. We can use the built-in list.sum function, and that's going to add them all together, and hopefully we'll see 142, and we do. So that's it. I'm going to save this, and I'm going to copy this over here in my clipboard, and I want to make sure that I'm keeping track of these links for the video description. That's where I'll leave it there. Let's see if the code works for the puzzle input. So I'm going to click get my puzzle input, and my puzzle input is this, but yours might be will be completely different. So the answer I get here is not going to be the same answer that you'll get. So I'm going to hit compile, and I get 54450. So with advent of code, the way we check to see if our code works is we paste that number into the text box here, hit submit, and it looks like we got it right. So that's part one, how every advent of code puzzle works. Each day it'll have two puzzles. So one will be kind of a simple problem or like a slightly easier problem than part two, which adds like a twist or some nuance. So it tries to test to see how well you wrote your code or how much you hard coded it specifically for part one, how flexible it'll be. So with part two, let's see what the twist that they add is, and let's see if we can we can finish day one. All right, part two. Your calculation isn't quite right. It looks like some of the digits are actually spelled out with the letters 1, 2, 3, 4, 5, 6, 7, 8, and 9. They also count as valid digits. Equipped with this new information, you now need to find the real first and last digit on each line. Whoa, okay. So here, this is 2 and 9. Oh, that's wild. So that'll be 29. And then this is 8 and 3, so that'll be 83. 13, 24. So I think we need some form of like a parser almost. So we need to work left to right and see if we can get some digits. This will be really interesting. Let's see how we can do that. So that's part one. I'm gonna actually name this, or I'm gonna undo. I'm gonna say advent of code 2023 part one. This is much harder than most part ones. Usually, or day ones. Usually day one's like a walk in the park. But we'll see. We'll see how this goes. I'm gonna save this again, and that'll be part one. Adding that to my notes. All right, let's figure this out. So with the new, actually, I'm gonna just pin this. So with this new information, it's gonna want us to get this and then add those values together. So a lot of our program's okay. It's just this part here is what's gonna need to change. So rather than using two calibration value, we're gonna have to do something else. So we're gonna use, I guess this is gonna be, we'll just call this 2 part 1 calibration value. And we're just gonna keep this here for reference. We'll actually delete this when we have our final answer. But this is going to take in each line one at a time, and it's going to return some type of change. So this code isn't going to run anymore. Now we're running this code, so hopefully we'll see separate lines here get printed out. Oop, filter map is wrong because we're not returning maybes. Oops, and then we're going to just comment out that sum temporarily. We're going to add it back in later, but right now we're asking Elm to add up text, which it does. It's like, what are you talking about, bro? That's crazy. All right, so what we want to do is we want to, instead of just matching on single digits, so before we were like, hey, let's just filter all the characters that aren't digits, what we want to do is turn these into digits, and then maybe we can do it. So I have a dumb idea that might work. I don't know if it will, but let's try it out and see how it goes. So I like what we had for part one's calibration values. But what I want to do is I want to transform the input before we get here. So if we go back to what we had filter map here. I'm just going to comment out these lines. And then what I want to do is I want to just replace, anytime I see 2, replace that with the number 2. Anytime I see 9, replace that with the number 9, etc. So the way I'm going to do that is I'm going to say replace words with numbers. And we're going to do that for each item in the list. So we're going to use list.map. I think this will be the easiest way to do it. We'll find out. So the way we can do that with Elm is we can say if I see 1, place it with the digit 1. And then we're going to do that all the way down. If I see 2, the way this fails is if there is a number, like the word 1 is like a subset of another thing. So we'll just have to be careful to make sure that we do this in the right order. But I don't think that is true for any numbers in English. So I think we'll be okay. So what string.replace does is it takes text on the left and it replaces it with a text on the right. So I'm entering those. The order does matter here. 8, 8, Did they mention 0? I don't think they mentioned 0 in the puzzle input. So it looks like these count. They didn't include 0. If the answer's wrong because they didn't put 0 in there, I'm not even going to be mad. But the idea here is instead of having 219, hopefully by the end of this, we get the number 2, the number 1, and the number 9. And it looks like it worked here. I think... Oh, this is interesting. See how that... Yeah, 8 is sharing a T. So this is what's really nice about doing it one step at a time, is that you can catch things like that. So if we... 8, 2, 3. Got it. So we can't do it just that way. Otherwise, we're going to lose the information. I have a hacky way that'll work, but I don't know how I feel about it. The hacky way is I just do the words backwards, do a backwards find replace, but I don't think that'll actually work. I mean, like, I have it going one way and then going the other way, but I don't think that works because it's arbitrary. Like, if 3 came first, I think it would break. So this doesn't work the way I wanted it to. So I think I am going to parse from the left. 8, whoa, 3. That's crazy. This is a crazy puzzle. 8, 2, 3. I could get the puzzle input to work by switching the order of these, but that's not going to work when I actually get to my like real puzzle input. It's just going to like be wrong for some unknown reason. So I'm not going to do it that way. There is a really hacky way to fix this that I'm going to try out. I think I'm going to try this. So see how 2 ends in an O and 1 starts in an O? What I can do is instead of doing these individual ones, I can just say, hey, if I see twone, that's a 2, that's a valid 2 and a valid 1. So I can take these compound words, and because I just have a finite set of things, this might be the fastest way for me to actually solve this. So let's see if anything else ends in an O. I don't think so. Let's go to 2, see if anything ends in a T. Looks like 8 does, so let's do that one next. So 8, 2. That's valid 8, 2. 8, 3 is also valid. And this is to prevent me from having to write like a parser on day 1. I don't want to do that. So I'm going to see if I can be smart. Nothing ends in F. We covered 8, the only thing that ends in T. Nothing ends in S. And then 8 and 9, I think, is the other one that I see. So nin 8. This won't work either because I could replace 9, 8. Yeah, it could be an infinite like chain. So I could have like 9, 8, 3, 8. Like those could all, I'll show you what I mean. I could have something like this. This isn't gonna work. You know what I mean? Like this could go on forever, and I can't. There's a cycle. So I'm gonna do it like a normal person, and what we're gonna do is we are going to go back to the drawing board. It was a fun idea. It's not gonna work out. Sorry, folks. But what we're gonna do is we are going to parse these numbers. We're going to look for a pattern. What I want to do is I want to loop through the string. I want to break it into characters almost. And for each index, I want to say like, is this a valid thing? So we're going to look at it like one letter at a time. And like if the letter is 2 or 1 or 3, that's valid. I almost want to keep this code somewhere. But I'm just going to comment it out so we have it typed if I do need to like grab it later, because we did already type these translations. So this might be a case expression. We'll see. So what I'm going to do is I'm going to start with this. So we have our original input. And then what I want to do is I want to go through each like letter one at a time and say like, is that like, I'll start with T here and I'll say, is this 1, 2, 3, 4, 5, 6, 7, 8, or 9? If so, like write it down and then go to the next letter. So we're going to have like a value that we're accumulating. We're going to be incrementing through each letter one at a time. So I think the best way to handle that is to do either a bit of recursion, which is just keep calling the function a loop, or we can do like a fold L. Think I think a fold L would be weird. Fold L would be like if I took all these things, turn them into characters. Oops, string.lines. I meant string.toList. And what I'd have to do is an index map. No, I don't want to do this. Oh, yeah, one thing you can do is break it up like this. I feel like I could take the string and kind of chomp it as I go and then keep track of the numbers. So what we're going to do is we're going to do this just to get an index, or we can do list.range 0 to string.length _1. So this is going to give us a bunch of indices. And then what we're going to do here is we are going to fold over that list. Fold L. We're going to have our index. We are going to have our string that we're building. So these are going to be like our nums. And we are going to return nums. So what we can do is we can, so let's say like, this is it. I think this will just return an empty string for everything. What we're going to do is we're going to take the, we're going to say like if string.starts with, 1, we're going to return 1 plus, that kind of thing. So if the string starts with this is like the dumb way to type it, and then we'll clean it up later. But if the line after we drop, no, string.starts with is right. After we drop so many, if it starts with 1, then we're going to do nums plus 1, that kind of thing. Nums plus this. And then we could keep doing this, like we could copy paste this. I don't think this is the cleanest way to do it. Let's see if the logic works. And then if it does, then we're gonna clean this up. We'll take a look at all the repetition and be like, what parts can we extract? Sometimes I like to do it the dumb way, and then I like to do it the nice readable way. Like this is not something I would submit to version control for my teammates to have to read. But it's definitely okay if you're just testing out an idea, if you wanna test it out that way. Boop, 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 boop. Because with only 9 numbers, it doesn't take too much to type. Too much time to type. 2, 3, oops. 4, 5, 6, 7, 8, 9. Engineering taught me to be lazy. Let's see if this works. I have a typo somewhere else. Nums. Nums value is not a function, but was given an argument. Oh, sorry. I had an extra nums dangling over here. Wow, that worked. I think that worked. Because now we just have numbers. And what's cool about that is we can plug that into our part 1 to calibration value. So I'm going to go back to the name we had. So everything we had before was fine. And we get 330. Is that the answer? No, it looks like it's 281. Oh, what the heck? 16? No way. They want us to do 16? Wait, what? That's crazy. 16. Does it go up to what? What does it go up to? Like 199? That's nuts. 16. Okay, well, I guess if it's 109, the last digit's 9 anyway, so it doesn't matter if it's 100, 200, 1009. So there's probably not that many we need to go through, but still, that was dirty that they did that. That makes me think that 0 is one of them. Okay, so for that reason, what we're gonna do is we are not going to we're not gonna type it out. I'm not gonna copy paste all these, though I am tempted to. Um, Gosh, that's horrible. All right, at the very least, what I can do is I can extract this, right? So to clean up the code, the very first thing we can do is be like, this is obviously something that we can move into a single, like a variable or whatever. So we can say word is the line, but we're going to drop this many characters from it. So then with this, just going to do this. We don't have to run that every single time. I kind of like the if statement. It's easy for me to read. I could make a list and then iterate over the list, but I don't know if that's going to be a performance issue that I'm accidentally causing by trying to make my code look pretty. So we're just going to be dummies. 10. Do it like that. 11. This is insane. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Wow, when does this end? 16 or 21. The 16 is throwing me. Did they say? This could go up to like forever? This could go up to like 3,468? Like, is that going to be like typed out here? Like, that's crazy to me. 1, 4, 76. Oh, no, 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 no. No, no, no. I misunderstood. 76. This is still 76. No, I'm off my my meds, you guys. All right. No, 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 no. That was not right. Okay. I did something wrong otherwise. So the way we can figure out what I did wrong is we can take a look. It looks like I got a 76. String starts with 7. Plays with 7. So before we get too far in the calibration values, let's just take a look at what we're getting back here. So I'm just going to return just the digits for now. So I'm going to do another trick where we just comment things out. Oops. And then just the digits. I want to see where I left off. Oops. Just the digits. I'm just going to do a map here. Sorry about the messy mess. As I change things, I'm changing the type signatures and stuff like that. So somehow 76 didn't come across. Oh my goodness, I'm throwing away numbers. This is 219, I'm returning 29. So if it's a digit, we just add it. So if string.isDigit. Sorry. If, so here's what I'll do. In the case where, how does this work? I want to take this, like the first letter, string.left one line. If I take like the first thing, and it's a number, basically, like if the head of the string is a number, I want to keep it. And I do want to add it. So string.toInt, just a digit. Let's keep it. Nums plus string.fromInt digit. Otherwise, we'll do all this crazy stuff. So that's what I did wrong. And I need to indent all this. I don't think this is going to format the way I want it to. Oh, it does. Thank you. All right. 219 is still not that. I take the first character of the word. Sorry, not the whole line. So there's our 219. There's our 76. Okay, my bad. Sorry, everybody. It wouldn't be a day one if I wasn't goofing it, you know? I gotta get back into the swing of things. Can't sum me. Oh yeah, I gotta do filter map. I changed that. All right, let's see how we do. 281, is that the thing? 281. Oh my gosh. When I saw 16, it was almost the end for me. I was like, you didn't say that. Total misinterpretation. Again, a classic case of like the puzzle input trolling. Like one of the puzzles last year, that happened to me. Okay, so I'm gonna save this. I'm gonna change the name here. I'm gonna say part 2, and I'm gonna save that again. Copy this over. Let's see if we can do a little bit to clean up the code. Maybe we should see if it's correct first. I'm okay with this. I know it looks ugly. I'm not ashamed. That's actually fine. I'd be more upset if I was duplicating this logic a bunch. But if it starts with 1, add 1, like this is actually very easy to read. It's not so easy to read when you just have a bunch of stuff just going off the page. It's just like, what are you doing, Ryan? So I'm happy with that. I think that's okay. We can delete all this extra stuff, and we can add back in this type annotation. And I'm just gonna click this little format button. By the way, I'm sure you caught on at this point because I've been using it. But I'm gonna copy that. That'll be in the YouTube video description here, part 1. And then let's try it with my puzzle input. So it looks like it hasn't changed. Pilot, and I get 54265. Let's see if that's any good. Day 1, 2 gold stars. All right. Well, that's it. That's day 1. I'll be back. I got to do this for at least 7 days, otherwise I get embarrassed. And then if I don't make it to 7 days, then I'll just never do it again because I'll be too scared to show my face. But thanks for hanging out. Sorry, day 1 took a lot longer than I thought it was going to take, but that's the cost of having a limited noggin. So I'll see you guys tomorrow for day 2. Take care and goodbye.